Hello, my name is Rick. Today I am going to show you how to compute factorial and pi with functional paradigm recursion. I know probably you have watched several videos before about how to do factorial, but I'm going to do this video a bit differently. And plus, I'm going to add up a pi function with a Gregory-Leibniz method of calculating it. And I'm going to offer you how to do the codes itself, either by browser or the terminal or editor, whichever you may like. You may to do so. And last, I will show you how did I implement recursion in my daily projects in a much complex way I haven't imagined before. Okay, but you don't need to be afraid. Recursion is essentially simple, but because we rarely use it, thus we think of it as hard to do. Okay, without further ado, let's do the code. First, I'm going to reduce the size of this my webcam view. Okay, and I want to put it on the corner. And here I've opened a browser, but we don't need the main page itself. The one thing we need is the inspect page panel. But first, since I'm a LibScript lover, a descendant of JavaScript, which allows you to do functional in JavaScript. Here's I show you. Yeah, you can read the documentation here, but we are going to read it later. Okay. Then we find from Scratch.js. This is an alternative console for doing LibScript code in the browser. Okay, I hope you install it, and let's go next to our code itself. Okay. Okay, Scratch.js is open. Okay, nice. So we are going to do the code here. First, let me remind you what factorial in math like. Fact, we abbreviate the factorial like this. Fact is a variable that return an expression which contains 4 times 3 times 2 times 1. Okay, then we console log fact and run it, or just press Ctrl Enter. It will return 24, as you may have guessed it. But we are going to make a function that when we pass a number to it, it will return that num times that number minus that number, and so on. So it will be like this. Factorial effect is a function that receives a number, we abbreviate like this, and will return the number. Okay, console log fact 5, and we run it. It returns 5 because it does nothing to the number we passed into it. But when we try to mimic the factorial formula like this, num times 1. What does it do? Oops, I'm sorry. Factorial num minus 1. Enter. It will get you an error. What does maximum call stack size is exceeded? It means that your codes run indefinitely. It don't know where to stop, so it returns an error. So when we recurse the logic here, we need to make a stop logic. So we tell the computer when to stop counting. So we tell the computer to return 1 if num is 1 and num times factorial of num minus 1. So when we execute it, it returns the right number. Why? Because when it passed 5 times factorial 5 minus 1, it will return 5 times 4, that 4 times 3, 3 times 2, 1 times 2 times 1. And when the factorial given number 1, it no longer run this line of code, but instead return a static number of 1. So, or you can write it like this: if num is 1, then 1, else num times factorial num minus 1. Then when we run it, it will return the same number. I hope you get the hang of a factorial function. You can save it for later. Now we are moving to calculation of pi with functional recursion. So what is pi? With you must know already how to calculate the pi with the simplest constant before. 22 divided by 7. When we console log it, it returns 3.24 and next, so on. But we are going to do the pi with Gregory and Leibniz way. What it is? Pi is 4 divided by 1 minus 4 divided by 3 plus 4 divided by 5 subtracted by 4 divided by 7 plus 4 divided by 9 and subtract by 4 divided by 11. You can see the pattern here. This is Gregory Leibniz way of calculating pi. As you can correct me if I'm wrong. As you can see here, the division keeps increasing by 2 for each iteration of calculation. 1, 3, 5, 7, 9, and 11. And for each steps, it switch the subtraction and addition of the formula. So how are we going to make a function that when given a number it will return a calculation which will reach from 4 divided by 1 to 4 divided by none. Okay, so here is how we are going to do it. Remove everything first. Okay, here is how I will write the function of pi. Pi is a function that when given num, it will recurse calculation like this: 4 slash divided by num plus pi that receive num minus 2. And to switch between the subtraction and addition, we need to pass a truth value. It is undefined yet, so it will be defined in the parameter. So this is the recurse logic, and this would be the stop logic. So we would like the pi to stop recursing when it reaches 1. So return 4 if num is 1. Okay, and we to pass the truth value, so it will switch between addition and subtraction. We need to make a variable named x. It's just what's in the name. If num is if truth, then 1, else minus 1. So when a truth value passed, when the truth value defined, it will return 1, positive 1. Or if the truth value is not defined, or minus, or negative, or falsy, it will return minus. So it will switch from addition to subtraction for each step. So we will put it here, which means for whatever result the recursion returns, it will be times x. Okay, so the console log pi of 15 would be minus 3.0. When we add the number to this, the higher the number we pass into the function, it will return a more accurate value of pi, like this. When we return a value more than 150,000, it return a maximum call stack size exceeded. But with 5,000 number, it returns a pretty accurate value itself. So that's how we do pi calculation with functional recursion. So this is the recurse logic and the stop logic, and this is the helper. Or we can write it like this: if num is 1, then return 4, then 4, then return 4, else 4 slash num plus times x pi that given a num recurse pi to pass the truth value and remove it, it still returns the right value. So that's how you do it. Okay, so what does recursive function do to us other than solving math problem? Actually, I had done several large projects with recursion that helps me solve a hierarchical data structure like the one I have here. Okay. This is a library. Okay. This is a library that I create to help people build forms easily by simply defining schema. So you can see here okay, input types. When given name and the schema, it will run through this object of logic, and then when they find array or object, it will call itself again. Input types call input types. So when someone declares a schema, it will run through it from object to arrays until it reach no more arrays or objects and return the condition we intend to do. So I hope it helps you. Probably I will do more tutorial. I'm sorry if my English were quite bad. I believe I can do it better later time. Okay, thank you so much for watching.